Welcome to lesson 2.2. Here we're looking at linear equations in one variable and we're going to solve them. We're also going to look at inequalities and how they represent relationships. To do that, we're going to first practice the algebra behind it and then look at some real-world situations they might appear. So if you don't remember how to solve one-step, two-step, or even multi-step equations from pre-algebra class, make sure you look through the examples and the other videos that'll help you with this. I'll work through the solutions for these next questions. So when we're solving for x, right, we have PEMDAS. When we evaluate, when we're solving, we're going to do the inverse. So inverse operations, right, when we want to undo adding, we do subtracting, multiplying, dividing our inverse. We'll learn more inverses as we go along. So adding, subtracting is first, so I'm going to minus the 4, and then I get 3x. Now it might help to do the line in between. Negative 12, so now I'm going to divide 3 on both sides, and I get x equals negative 4. When I have variables on different sides, I need to get them together first. So I like to add or subtract the smaller, right? Negative 2 is smaller, so that's one I would prefer to move. And now it looks like the one above. So I'm going to subtract the 15. I'll get negative 9 equals 7x. And then I need to divide by 7 on both sides to get x alone, to isolate x. And then sometimes you might as well just leave it as a fraction to make it a mixed number, right? That might help also. So I would divide the 9 by 7 and then rewrite it as negative 1 and 2/7. Check which one your instructor wants. And then the last one, here's a lot of variables and numbers. If I see parentheses, I want to distribute those first and then see if I can combine anything. So I can combine those that I give me negative x. I can combine the numbers, positive 11. On the right hand side, I combine the 5 and 12. And now this looks more similar to what we've seen. I will add the 3x. Sorry about that. I will add the 3x to both sides. So I'm going to get 2x plus 11 equals 17. Subtract 11 on both sides. 2x equals 6. So then I can divide by 2 on both sides. And I'll get x equals 3. So then we're going to use that to go back to our taxes. So now we're applying the algebra we learned. Right, we learned linear equation. All right, I mentioned that already. That's where every term is constant. There's only one variable. There's no powers. And then we have what's called our input or independent variable and our output or dependent variable. So some other terms that we want to make sure we know what they mean. Okay, so using the formula provided, so that would be this one, find out how much tax is owed with wage income 30,000. So that means plug in 30,000 for W. So I'm going to take that formula equation that we were given, plug in 30,000, and then evaluate. Okay, so I had to rewrite the parentheses, but I got 252375. So 2,523 and 75 cents. Now using that same formula, find the wage, wage income if we're given taxes. So that means I have to plug in 3,423 and 75 cents for the taxes part, and then I need to solve for W. So just because they're bigger with decimals doesn't mean we do anything different. We're still going to add, subtract, solve for that variable. So I'm going to add the 1976.25, but this time you might feel more comfortable doing it with the calculator. That is perfectly fine. I'm going to pull up mine as well. So plus 1976.25, I get 5,400. And then 0.15 of W, so that means I need to divide by 0.15 on both sides. Right, and it might feel weird doing this, but those are the steps. That's why we practice the steps with whole numbers first. So 36,000 is their wage income. Inequalities, we've talked about those before. Less than, right, greater than, equal to. We also have less than, equal to, or greater than, equal to. So we have some examples, right? If it can only be greater, you have an arrow. If it has to be between two numbers, right, we'll see the dots. So less than and greater than, those are going to be open dots. And if it has that equal sign under it, those are going to be closed dots. And then we also have something called interval notation. So interval notation is where we use parentheses or brackets. For the less than and greater than, you will use parentheses. For the closed dots or the less than, equal to, greater than, equal to, we'll use what's called brackets. So you see some examples. Make sure you look through those. It'll give you the inequality, the graph, and the interval notation. You'll need to be familiar with all three of those. Here's a good comparison chart of what all of these different types of statements look like. And your job really is to get familiar with interval notation and inequality notation. So if I have this 3 and going to infinity, I need to be able to write that in a different notation. And you need to use your computer to be able to do that. So that's what this is helping you practice. When you're solving inequalities, you're going to treat them very similar to equations, but the only difference is when you multiply or divide by a negative, you have to change the symbol. So that is the key difference between inequalities and equations when you're solving. And we have these extra videos for you to look at and practice. So remember, we've done this before. We've solved equations. All right, just work on both sides. 2x equals 3, so I'm going to divide by the 2 on both sides. X equals 3/2, or 1.5, or 1.5, however you want to look at it. If it was an inequality, then I would do the same thing, but this time x is less than or equal to 3/2. For interval notation, it might help to graph it first. So I'd find that 3/2, which is 1.5. I'm using the closed dot because, or equal to, and then the arrow is pointing to the left. Right, so this is that this should match this symbol. And that's how I look at it. When you're solving something with numbers on both sides, you have to do the same thing to each part. So I'm going to subtract the 5 from both sides, actually all 3 parts this time. So -4, screen got away from me, 2x, and then 3 divided by 2 like we did before. So I have -2 is less than or equal to x, which is less than or equal to 1.5. So 1.5, oh, that's not a less than or equal to. That's just a less than. So it's going to be open dot. And the -2 is going to be over here, closed dot. And then I'm going to put a line in between the two to show that it's only in between those numbers. So for my interval notation, it would be, this was my inequality notation. Interval notation would start at -2 and go up to 1.5. Bracket because it's closed dot, parenthesis because it's open. I think, yeah, I forgot to do it over here. So this was inequality notation. Interval notation, it doesn't have a starting point, so that's -infinity. If it has no ending point, it would be positive infinity. And we stop at 1.5, but it's included because of closed dot, so it's a bracket. So that's what you'll be practicing for this lesson.